Guys, welcome to this channel. Today we will discuss some MCQs from the chapter Thermal Properties of Matter. It's in class 11th Physics, chapter 11. The first question here is the form of energy transferred between two systems or a system and its surroundings by virtue of temperature difference is called as heat temperature, both A and B, and or none. So obviously, something that flows from one system to another or between two parts of a system is the heat. So a system is something that is under observation, and anything beyond the system is surroundings. Okay, question number 2. The SI unit of heat energy is. So basically, heat is a form of energy. So the unit of heat should be joule, Newton, Pascal, or Newton squared meter. So obviously, joule is the correct answer. Question number 3. The SI unit of measurement, the SI unit of temperature is. How should we measure the temperature? What's its unit? So if you carefully look at the options, that's Kelvin, degrees Celsius, degrees Fahrenheit. So what should be the SI unit of temperature? Obviously, these are basic questions, and you will be asked the basic questions because the syllabus is showing that the questions will be basic type from the 11th 12th physics, chemistry, and bio. So here all the options are correct. Option D is the right answer. Then we have question number 4. The commonly used unit of temperature is. Usually we use, if you hear about something, in our own mother tongue as well, we usually say that the degrees. So here the degrees Celsius is the commonly used unit. Okay, question number 5. Charles law is given by. We have Boyle's law, Charles law, Gay-Lussac's law. There are other as well as other laws, but here we are asked Charles law. So Charles law says V is constant, that's volume is constant, volume by temperature is constant, or temperature is constant, or none of the above. So clearly volume by T is constant is the right answer. Let's move to the another question. The Boyle's law is given by. Boyle's law implies P is constant, PV is constant, V by T is constant, none. So obviously option B is the right answer. B is PV is constant. Then we have another question, question number 7. Ideal gas equation is given by. A is equal to PV is equal to nRT, PV is equal to RT, PV is equal to R by T. So PV is equal to nRT is the right answer. The numerical value of universal gas constant is given by. So universal gas constant, that's which is represented by R, and which obviously is in the ideal gas equation. R has a value given by 8.31 joule, or B option 8.31 joule per mole per Kelvin, or 8.31 joule 31 joule per mole, or none of the above. Clearly 8.31 joule per mole per Kelvin is the right answer. All right, question number 9. That absolute zero temperature is given by. So absolute zero temperature is in Kelvin scale. We usually discuss this in physics and chemistry. So it is minus 23, 273 minus 273.15 degrees Celsius. All right. Then we have question number 10. The increase in dimensions of body due to the increase in temperature of the body is called as. So when you heat a substance, there is a high probability that the substance will expand, its dimensions will change. That's called thermal expansion. So if the dimensions change or increase, the substance is going through thermal expansion. Okay, okay. Then we have another question. The expansion in length is called as. So if the expansion happens in a one dimension, we call it as option B, linear expansion. Question number 12. The expansion in area is called as areal expansion or area expansion. So we have question 13. The expansion in volume is called as. It's totally obvious and clear from the options. You can directly guess the answer without knowing anything. So it is volume expansion. Okay, question number 14. The change in temperature of the body due to heat absorbed or rejected by it is called as heat energy, entropy, enthalpy, heat capacity. So it is heat capacity. Heat capacity is the amount of heat required to reach the temperature of body. Alright. The SI unit of heat, specific heat capacity is heat capacity when described per unit, per unit mass or per unit per molar per unit mass. We said specific capacity. So it is joules per kg per Kelvin, joules kg Kelvin or joules per kg or joules per kg per Kelvin, joules per kg or Kelvin. So option A is the right answer. The SI unit of molar specific heat capacity is. In the previous question, in question 15, we had per kg. Now we have molar, means joule per Kelvin will be same. The only thing that will change is per mole. So option B is the right answer. So question 17, sorry. Sometimes the answer gets totally visible to you, but yeah, it's okay because still it helps in the isolated system temperature of the system. All right, an isolated system. What happens to the isolated system? What happens to the temperature of the isolated system? Should it increase, decrease, remain constant? Not confirm. We don't know. So the temperature of an isolated system should remain constant because an isolated system is something that is totally insulated, that is totally separated from the surroundings. There is no transfer of heat to or from the system, so it remains temperature remains constant. Question number 18. The device used for measurement is called as, for heat measurement is called as thermometer, barometer, calorimeter. So what is the device used for heat measurement? Should be thermometer? No. Barometer? No. Calorimeter. Calorimeter means heat measuring device. Question number 19. We have the change of state from solid to liquid is called as, when an object changes state to liquid is called. So it is called fusion, melting, vaporization, none. So it is melting. Okay. The change of state from liquid to solid is called as, when a substance changes from liquid to solid. What should be the process called? It's called fusion. Okay. Melting and fusion are opposite. Question number 21. The temperature at which the solid and liquid states of the substance in thermal equilibrium with each other is called as. So at which temperature the solid and liquid states are in thermal equilibrium. So is it boiling point? Is it freezing point? Is it melting point or not? It's totally melting point. When solid changes, when ice changes into liquid water, so the change happens at a constant temperature. That is soil, that is both ice and liquid at the transition state. or at the same temperature. That is thermal equilibrium. Question number 22. The melting point of the substance at the atmospheric pressure is called as at the melting point of the substance at standard atmospheric pressure is called. All right, what is the answer? Thermal normal melting point. It's like melt at a standard atmosphere. If it is measured at the standard atmospheric pressure is called a normal melting point. So question number 23. The change of state from liquid to vapor is called as freezing, boiling, melting, vaporization. So when a liquid changes to vapor is vaporization. 24. The temperature at which liquid and vapor states of substance coexist is called as boiling point. Okay. Last question. The temperature and pressure at which the fusion curve, evaporation curve, and sublimation curve meet all the three phases of the substance coexist is called as. So what should be this point called? So it's triple point. Thank you.